Welcome back to Stranger Than Fiction News, broadcasting live from the dark side of the planet. Today we're going to be talking about long haul COVID, chronic COVID. And of course, since the beginning, we've been talking about this like it's airborne HIV and not some kind of flu virus that just comes and goes. And we're seeing more and more reports in the mainstream media that, in fact, this is a chronic systemic disease. Of course, we're broadcasting live out there. How's everybody doing? Waiting for people to enter into the show. Maybe we'll snag some of these poor people that are crying, screaming, complaining about long haul COVID, and nobody's got the answers. We've got the answers, ladies and gentlemen. We've had the answers since the beginning. Nobody likes the answers, but we're going to continue on broadcasting anyways. Heavy censorship is happening right now, and we're basically off just about every platform this page is about to go. And so be sure to bookmark our BitChute channel for more. Let us not delay and get into the core of the news. We've got a lot of news to cover, a lot of real interesting aspects about this virus to cover. But before we do, I just want to reference some of the articles that are circulating right now. Infants dying from COVID. They say a lot of children dying from COVID, causing permanent heart damage, brain damage, all sorts of inflammation-related diseases. And it almost seems separate to the primary infection, which is, the initial bout with the virus, which is mostly respiratory in nature. But it seems like it burrows, it hibernates, it goes into a latent phase like many viruses. It maintains a colony somewhere, could be in the, white blood cells, the memory cells, could be in the spleen, in the lymph, other places. But you see a lot of people posting about COVID, long COVID, and we're going to be getting into what some of the health professionals are saying. We need to talk about long COVID. They say many who have it to continue to experience complications after their initial illness, and there's all sorts of threads that people can go through. Are you interested in this? Maybe you should be, because we see a lot of people exhibiting signs of a chronic illness, and that usually means that it is a chronic illness. It just kind of depends, when you'll experience it. With HIV, it can take many years before people become symptomatic. Sometimes it's less than a year, but not everything is like HIV. Any case, we really want to get into some of the other things that kind of piqued our interest here, ladies and gentlemen. There are many open reading frames when it comes to this virus. Let's see if we can expand what we're seeing here. And not sure how many people are into molecular biology and all of that stuff, but we're going to try and explain to you what we're looking at generically here, if the video guy can cooperate. Essentially, the genetic code of this virus is about 30,000 base pairs, or 30,000 letters, every 3 letters coding for an amino acid. These amino acids group together into polypeptides, and if they're long enough, they'll fold into a protein which has a function based on its shape, like a bottle opener. In any case, the coding of this virus of the 30,000 base pairs is broken up into what's referred to as reading frames, where you'll have this molecular machine basically print, kind of like 3D print, what this code represents right there in the cell. It's a very interesting kind of thing. Now, what we're going to be talking about are all of these little extras here at the end, and these are known to be accessory proteins, but it gets a lot more interesting than that. Now, some of this codes for the spike protein right there. This is the envelope protein. This is the membrane protein. This is the nucleocapsid protein. But all of these things that are numbered 3A, 6, 7A, 7B, 10, etc., they actually produce a bunch of different micro machines. And essentially, these micro machines do all sorts of things in the cells and in the bodies. And, you know, some of them essentially help with assembly, but, you know, in the classic kind of thought of, you know, how viruses reproduce. But many are, you know, basically there to interfere with cell processes, to essentially mimic what other molecules do in the cell. It interferes, it inflames, it hijacks, it mimics. And essentially, we're going to be looking a little bit at some of these open reading frames. 3A, 6, 7A, 7B, 8, and 9B. But all of these basically code into things that are very disturbing, to say the least. We'll give you an example here. SARS coronavirus open reading frame 8B triggers intracellular stress pathways and activates inflammasomes. And essentially, we're seeing that, you know, there's some of this code that's basically programmed to make your immune system run wild. And essentially, that's the whole purpose. That's what it's delivering. It's kind of like a stealth fighter, and this is the package that it's delivering. You know, one of the packages that it's delivering. And it's this huge, basically, internal inflammation. And we're seeing this, you know, readily described in pathologies of children right now. And of course, children are getting probably better health care than adults. You know what I mean? And so they're taking a little more time to figure out exactly what's going on with these kids. And so one of the things that we're seeing is just basically general inflammation of the internal organs. And this is just like one small package of this subset of codes. And it's really weird because we're going to get into it, but, you know, some of the things that this virus manufactures once it's in the cells are really like small little peptide chains that go and find and cut proteins of the host cell to basically sabotage, like, you know, cut it, you know, at the Achilles heel. It does all sorts of things. So, you know, we found this interesting, so we want to kind of progress and hopefully get, you know, give you a better idea of what's in this virus, because that's really what we've been looking for, is what's, you know, inside the virus. What does it code? Here we see in frame 9B, SARS coronavirus suppresses innate immunity by targeting the mitochondria and signal pathways. And what they're seeing here is that there are certain proteins that are manufactured because of this virus that are congregating in certain places inside the cell. How's everybody doing out there? So we could get into this, but we're going to come back to it, I think. See what what kind of time we have, but essentially localizes in the mitochondria, causes mitochondria elongation by triggering degradation, host protein involved, etc., etc. So this just illustrates like what one little package can do. Accessory proteins 9B and 8B and 8AB of severe acute respiratory syndrome suppress the interferon signaling pathway. And, you know, that might not mean anything to you, but the interferon pathway is basically a huge thing in the immune response. So here we've got proteins that basically suppress the immune system's ability to recognize the virus. And we see other little things that it has, you know, in ways that it can cloak and hide. And essentially, you know, that's what we're dealing with in the chronic COVID. There's latency somewhere, most likely, you know, in the memory B cells, but could be something else. What do we have here? Severe acute respiratory syndrome coronavirus is an inefficient inducer of interferon response. It expresses various proteins that effectively circumvent IFN production at different levels via distinct mechanisms. So it's sending out like all sorts of countermeasures as soon as it starts the infection. And this thing goes everywhere, you know, the brain, the heart, the kidneys, the liver. And as soon as it starts, you know, colonizing organs and tissues, it's setting off inflammation, suppressing immune response, cloaking, and the like. And, you know, it's just, it's like warfare. But also it's like, you know, a hardcore, you know, weapon that is introduced into, you know, people's organism. And of course, most people were infected with this engineered virus back in January, February, and March, and have been chronic ever since. You know, the severity of the symptoms will probably depend on a lot of factors, but we're seeing that in some of these subsections, if you will, it looks like it's tailored to certain genetic markers that we're just not really, you know, aware of yet. It could be, you know, blue eyes, it could be, you know, black skin, it could be anything. But we see that with certain of these coding regions, we've got specificity that has yet to be fully understood. We're just going to continue on because there's just so much here. SARS-CoV-2 NSP1 binds to the ribosomal mRNA channel to inhibit translation. So this thing, you know, comes in like a wrecking ball, and immediately it like sends out like a bunch of, you know, suicide bombers to blow away proteins and then to inhibit like host protein production. Then it floods like the cytoplasm with its mRNA and just basically, you know, translates into an overexpression of its proteins versus the host protein. So it's really a, you know, it's really a nasty little virus on all sorts of levels. We're going to continue on with some of the other discoveries. Again, you know, we're looking at the, you know, different reading frames of the coronavirus itself. Each one of these little blocks here represents a specific program or function, if you will. And, you know, some of these things are really like polyvalent in the sense that they can be chopped up into many different parts and even recombined with other things to make like, you know, a super cruise missile, if you will. We're just beginning to understand what this thing really does. But so far, the research that's coming in is rather interesting, because it's more than just the flu. It's more than just pneumonia. That's what people really haven't understood yet. Not sure what happened to this particular document. We'll see what happens as it reloads. Not sure if the matrix is gonna try and interfere. It looks like we're getting some interference. It may bounce the stream. You never know. These people are so desperate these days. You can't talk about anything that isn't like, you know, pro creepy bite. It seems like everything is just taking a dump right now. The whole thing is just taking a huge dump. I'd be surprised if we're still online. This is just ridiculous. The video guy is fired. We'll try and jump in to see if the stream is still live. Say hi to the audience out there. I'm not sure how interesting this is for you, but we're just warming up for another big show. Ladies and gentlemen, it seems like there's a few of you out there. How's the stream? How's it going out there? Big shout out to everybody in the audience. You can see yourselves here. Let's see what else we got. So big shout out to everyone out there. Has this thing loaded up yet? Yeah, okay. Back to original size. The coding capacity of SARS-CoV-2. So we're looking at, you know, some of these reading frames, what's in them. And just like every hacker, I mean, you want to know, you know, what's in it. But, so we kind of lost our place here with this reload. So this article, and you know, maybe we should come back to it so you can find it for yourselves. You know, just search for the title, The Coding Capacity of SARS-CoV-2. This was an interesting one. We have another one too, which is really like a resume of all the studies on the open reading frames right now. There's a lot of information to cover. And, you know, we really haven't structured this into, you know, a nice presentation at all. But we just kind of want to give you a preview, a taste of what's in this virus. The open reading frames include several in-frame internal open reading frames lying within existing open reading frames, resulting in truncated products, as well as internal out-of-frame. Okay, let's see. Which generate novel polypeptides, such as a 97 amino acid polypeptide that is translated. Okay, this isn't the juicy stuff yet. We're just trying to get into it. Let's see, indicating that the genomic RNA harbors unique features. Okay, hold on. You know, bear with us here. Upon cell entry, two overlapping open reading frames, etc., etc. Hold on, we'll get to it eventually. I think this breaks it down into the distinct regions, or else it's this other one, which I think is probably more interesting than the one we were just on. But for the sake of making the point, I think we'll just kind of start with this one because it classifies these regions a little nicer. Polyprotein 1A derives from polyprotein 1AB, which is cleaved into 10 proteins, NSP1, NSP10. So this is like on the first open reading frame, and like, you know, the first one is just like cut up into 10 different proteins, viral proteins that disable host defenses and support viral replication. NSP1 derives from residues, etc., etc. And let's see, you know, we could spend a lot of time on, you know, the procedures and programs that they're using to basically compare, you know, novel molecules to known existing shapes. Everything in molecular biology basically revolves around, you know, the lock and key kind of model, and, you know, shape determines function, and things basically just kind of fit together like Legos in a way. And so essentially what they're doing here is they're analyzing all of these different reading frames, and transcribing the protein from that code to make a shape based on known physics of chemical bonds and the like, and they get a pretty good idea of what these things will do for the most part on a real kind of generic genetic analysis. But some of these things that they're finding here are things that they've never seen before, and other viruses, shapes that they've never seen. They don't know what the functions are. But again, the idea here is that we're seeing a lot of, coding for different, little micro machines or proteins that actually go in and reap all sorts of damage in the cell. And of course, we haven't even really talked about the systemic infection yet, the long haul side of this yet, but we're still going to continue on with brief descriptions of some of these regions. And again, this is kind of referencing that map is gone now. Anyways, it's referencing regions on the virus itself, which are referred to as open reading frames. But these open reading frames basically translate into a protein, which is a micro machine. So you think of protein as kind of like, muscle, like chicken or, steak or something like that. But, proteins are all sorts of machines. And, muscles, I guess, is just kind of like one example of that. Anyways, what else did they find? Essentially, they're finding that this thing mimics like all sorts of, chemicals or other proteins. It basically interferes. I think we have like something set up here that's somewhat more organized. Hold on a second. Here, now we're going to impress you. Let's see, suggesting it adapts to host-specific defenses. So there's a region for that, host-specific defenses. Suggesting it is well adapted to specific hosts. We're seeing like essentially some parts, have either a higher or lower mutation rate, and they're basically suggesting here that the higher mutation rates in some of these specific coded regions is because the virus is trying to find new shapes for, every person that it basically infects. And so we're seeing, a lot of adaptability that is basically host specific for whatever reason. But essentially, it's kind of like at first it gets its teeth in you, and then it's just like it never lets go. Essentially what we're looking at. And let's see what else we got. We got more. Let's see, suggesting these host proteins may be mimicked by the virus. Originally we were thinking like, oh yeah, we're just going to read all of this on air, but we're looking at 100 pages at least just in this batch. And so we're just really going to have to give you a summary. But this one was really kind of like an eye-opener too. This one was titled SARS-CoV-2 Structural Coverage Map Reveals State Changes That Disrupt Host Immunity. That's a mouthful. But, it's like a smart virus. It adapts, it senses, it feels, it sends out all sorts of countermeasures. And it's a nasty program. It's a very nasty program. I know we've got more things that were really interesting, and it seems like every research team is picking up like different sides of what each particular open reading frame does, and we're seeing that some of these reading frames are polyvalent. Let's see. ORF7b, an integral membrane protein thought to localize in Golgi compartments and the virion envelope. 8 is thought to inhibit type 1 interferon signaling. 9 is a lipid-binding protein thought to interact with mitochondrial proteins, thereby suppressing interferon-driven innate immunity responses. So let's see what some of this discussion is all about. And let's see. Using the current structural data, we can divide the 27 SARS-CoV proteins into 4 categories: mimics, hijackers, teams, and suspects. There you go. That's interesting, isn't it? We found structural evidence for mimicry of human proteins for only 2 SARS-CoV proteins, NSP and 13, etc., etc. Hijackers, we found direct structural evidence for hijacking of human proteins for only 2 proteins, the spike glycoprotein. And this one, we have a feeling that this does more than just open the door. Essentially, it kind of looks like each one of these spike proteins is also kind of like a bee stinger, and it can do all sorts of damage all by itself. And once this thing kind of like cleaves open and merges with the cell, these spike proteins are also kind of doing something else. But everything is, all of these different parts in this virus are doing something nefarious. Suspects, I know there was some like really spooky paragraphs in all of this mumbo jumbo here, but we're just not stumbling upon it yet, but we'll get there eventually. Group 1 proteins, etc. Let's see, maybe group 2 proteins were a little more notorious. I thought there was like a real notorious paragraph right around here, but whatever. These are structurally dark proteins, meaning not only is their structure unknown, but they also have no significant sequence similarity to any experimentally determined 3D structure. But there was more creepy stuff beyond this. Way more. It must be in this one. But again, these are just like huge summary documents that are just not all that interesting to read. But essentially the feeling is that this thing just shoots out all sorts of, nanotech into the body. And essentially what we're probably looking at is that once the primary infection kind of burns through and does, the initial damage, then it basically hibernates somewhere. It goes latent somewhere, like the spleen or who knows, the immune system itself. And then essentially it's basically producing viral RNA like on the down low, and is just like, having some kind of like detrimental effects, basically setting up, other parts of the program. And what was really nefarious, I should say, about all of this, and I don't know if we'll get to it or not, to be honest with you, but essentially like, one thing in this program basically opens the door for something else. It's like, Pandora's box in a sense. And what we see is that as it's allowed to progress, in its code, in its script, then it unlocks new mystery boxes, essentially. And this thing is doing something else, and then this thing is doing something else, and it builds up and it crescendos. And, a lot of epidemiologists are looking at this and make a clear distinction between the primary infection and what happens after that. And it seems like what's happening after that is some kind of autoimmune response, like all of a sudden the immune system has gone, retarded or something. But in fact, it's being provoked. It's like there's like this virus acts like an antagonist in a sense. And, we've got these documents for that. And all of this is like from Nature, cell death discovery, all that stuff, all the good stuff here. But SARS coronavirus open reading frame 8B triggers intercellular stress pathways and activates inflammasomes. And there was, other things like this thing is, basically opening up basically the self-destruct code for the cells as well, but not in all cases. It's just we see a wide spectrum of genetic expression here. Like, a lot of the cells will just continue to produce virus and bud, but sometimes you'll have a kind of like a classic virus exploding, bursting out of the cell, like the movie Aliens or something like that. I know we're missing like an article here because we had something about like the necrotic pathways of the cell. Not sure what happened to all that, but essentially all of these different sections of the virus are unleashing, a whole lot of proteins and things like that to essentially break down the immune system, prevent the body to cope and the like. I think we should kind of come back to what can you do. There's a lot of people talking about being long haulers, being chronic, and they're feeling fatigue, they're feeling all sorts of symptoms, and some of them are described as good days and bad days in terms of being able to think clearly and remember things, etc. And you might think, oh, this is just dementia for old people, but we're seeing a wide range of people being affected by this. And so right now, given that inflammation seems to be like the secret weapon really of this virus, it seems like it that's its main package. And so anything you can do to bring down inflammation naturally is going to help. Now there's been other things that they've documented that helps at this stage, supposedly like steroids and other things, perhaps different types of heart medications. But inflammation is key. Inflammation is really like what triggers the damage. It's almost as if this is like a type of like flamethrower, but you can't see the flames. And on the inside, it's just inflaming tissue and the like. So again, more of the same in terms of the big picture. This is a type of lupus kind of disease, an autoimmune disease that's caused by this flamethrower type virus that essentially codes for inflammation. It's not just some kind of like side effect, like, oh, it's going after the virus and it's just overdoing it. This virus essentially is coded to inflame everything along its path. And some people will be more or less well adjusted to the effects of this virus. We don't see necessarily the same type of symptoms with young people for the most part, but we are getting quite a bit of evidence that essentially everything is getting inflamed by this virus. And I'm sure we've got more exciting examples of that if we can get to it. But no, I'm not feeling the Matrix today. Anyways, we're talking about the long-term damage, the chronic COVID, heart damage, even in children, infants being reported killed. But we're hearing about some people getting better and some people getting worse with this chronic COVID as well. Obviously, going outside, getting sunshine, real sunshine and fresh air is going to make a lot of difference. Exercise. Some people, aren't able to exercise like they used to. Here's an article about coronavirus attacking the brain. And we're seeing actually more and more of this. New York Times, this is now, mainstream media. Not sure if people are really registering all of that, given the, difference of opinions in terms of, is this virus real? And, the scientists sure think it's real. The tests, these papers here, I think are really interesting for another reason. Essentially what they're doing is they're taking sections of this virus, the code that, people are finding on, in the gene bank and the like. And they're essentially programming it into pseudoviruses. I'm not sure if we can find any of the graphics of the open reading frames now. But they'll take like one of these open reading frames and they'll put it into a virus to see what it does. A virus that's got nothing else but this, basically genetic expression, just to see what it does in cells. And so they can isolate, a gene. And the way they isolate genes is because essentially, it has a start and an end code, kind of like, C++ or HTML, start, end. Essentially, that's how they know that these are open reading frames, because they just look for the start codon and then they look for the end codon, and then that's a frame. Now, not everything codes for something, but essentially it's a lot more complicated than you might think. It's a lot more complicated than you might think. The way genes are regulated at the molecular level is mind-blowing. And the way all of these little micro machines work, it's mind-blowing. It's beyond like, oh, you've got the genes for blue eyes and good looks. I mean, you've got genes that do things you can't even imagine. And this is all happening, autonomously as you're, enjoying being conscience. But eventually we'll get to the open reading frames again. This is like, the beginning of it. This is a type of analysis of it. But essentially, in some of these sections like 1A, 1B, it's divided into different subproteins. And you've got, depending on, what the virus needs, it'll make a clip here in its, polypeptide chain, or it'll make a clip here. It'll actually, cut out these codes, and it'll, just fold it into the shape that it needs. It's, it's worse than you can possibly imagine. But essentially, what they're doing is they're splicing out parts of the code, putting it into another virus, infecting cells that are in medium, or like, cow serum and the like. And they're growing it, culturing it, and seeing what it does. What are the characteristics of the cell after that infection. And so, this makes it, this makes the virus a little more real, because you've got all sorts of labs that are running experiments like this. And, there really isn't a whole lot of labs out there that are like, there is no virus. Now, the one peculiar thing, and I will just throw this out there for all of the no virus people, because you can't really rule anything out, but most clinicians will say that, they can't find any traces of the virus. All they find are traces of the disease. And that's a very important thing to note, because it's as if these people have been like radiation burned and they're looking for a virus and they can't find it, essentially. That's kind of like what it's like, really. But, what is this code that, all of the scientists are playing with? And, and the like is another question. We could spend all day on, PCR tests and antibody tests. I think, eventually anybody that's tuning in here because they're long haul, hoping for a cure, the best thing that we can suggest at this stage is, being at 110% on all of your vitamins and minerals, and, making sure that you stay there throughout your day. Get plenty of sunshine. Eat things that you might not normally eat, like, liver or something. All sorts of good foods, spinach, all that stuff. But essentially, you really want anti-inflammatories, herbal anti-inflammatories. Go to the organic store, get yourself a detox elixir with, all of the anti-inflammatories that you can find. And don't overdo it. No overdosing. You can overdose on everything, even water. But a little bit of this, a little bit of that, as long as it's natural and organic, it should be okay. Test your tolerance, of course, to new treatment options. But in any case, usually all that kind of stuff does the body good anyways, and you might feel that something works better than others. Magnesium is strongly attached to fatigue, lack of magnesium. So for most people that are experiencing the fatigue, a dose of magnesium every day, a nice dose, probably you want to be at 200% the first few days. But high quality magnesium supplement with all of your other vitamins and plenty of sleep, and that should do it. A thing that people have noticed here is that speaking makes it worse. Talking makes the COVID worse. It's like they don't want you to talk. So this COVID talking will make it worse, and so will wearing the mask, of course. And look, we haven't been able to cover nearly a fraction of what we really wanted to, but it's just kind of like, live brainstorming, find new ideas here. But thinking that, our time is running out for this broadcast. But look, what you can do for long COVID is to not push yourself. And, losing an hour of sleep will be magnified, basically 2 or 3 times with COVID. Have all your vitamins, minerals, fresh air, sunshine, sleep, eat right. Disease management is really going to have to be a priority, since there really isn't like a pill that you can just take. You're going to have to do everything you can to make this better. Baking soda seems very promising, almost as promising as hydroxychloroquine. We recommend 1 to 3 teaspoons, not tablespoons, and really little teaspoons of baking soda per day, 3-5 times a week. But check your tolerance, and if you have questions, certainly check in with a doctor. We're not a licensed physician in your county, or any county. But let's see, what else can we say, really? But the obvious. But the magnesium should really make all the difference. Anti-inflammatories, just in case, because this thing has a tendency of flaring up like herpes. And the flare-ups could be just relapses, or they could be, aided by reinfection. And so if you get reinfected, if you get a dose somewhere, that's going to cycle through you, cause the brain flu. And so as that happens, you'll be having a period of good days and a period of bad days. And most people really won't be able to make that distinction, really. But, when you get reinfected, either through food or, breathing in a decent dose, it'll eventually, come to the brain. Just like, smoking cigarettes or weed or, drinking alcohol. How long does it take to get to your brain? Not that long at all. So that's something to think about when you're taking a big breath of this stuff out in the grocery store. But look, at this stage, we were kind of talking about a little bit about, them not being able to pick it up in the test. In the severe cases, they see all of the signs, and there's just nothing that picks it up. This thing looks like it, it burrows quick, and it doesn't stick around too much unless, it's easy pickings in some of these, primary infection sites. So, chances are that it's done its damage and it just kind of disappears, self-destructs, and leaves behind something probably similar to, you know, the Moderna vaccine, where you've got this script or this code that's, you know, running around and you know, producing, you know, viral proteins. And that's really going to be the thing, because, you know, antigen tests for the most part are specific to probably the spike protein. This is probably the big, you know, takeaway now that you think about it. You know, imagine this thing just comes in like a pill, self-destructs, dissolves, and then starts mass producing viral RNA without, you know, necessarily having to, you know, be a virus all over again. But essentially, if it does that, you know, if it's only making, chances are this thing is only making like really a couple of these proteins in the dormant latent phase, the chronic phase. And those proteins have nothing to do with the spike protein. And most of the antigens, antibody tests, you know, are going to be looking for the spike protein and none of these other proteins. So the spike protein, I don't know if we've got a better diagram of this. Probably not. It's not going to... here. Okay. So essentially, you know, all of these open reading frames make different micro machines. And the idea here is that, you know, after the primary infection, essentially, you know, let's just say it infects the memory B cells, kind of like, you know, herpes. And it just lays dormant there. And, you know, it uses those cells just to produce like some of the proteins, but not all of the virus. Now, if all of the antigen tests and PCR tests are picking up, you know, trying to pick up, you know, little sequences on the spike protein as markers, it's not going to pick up anything else, really. And so it's going to miss the infection, give people the all clear, or just, you know, pick up, you know, a small percentage of people that are actually like, you know, flaring up. And so they have spike protein again. But that's really kind of like an interesting line of thought for myself, maybe not for anybody out there in the audience, but yeah, I'm going to run with that in a future broadcast. But you know, they've been able to, you know, pinpoint a couple regions that are highly specific to inflammation and immunosuppression, and, you know, there might be a few more. But, you know, in the long run, this thing might be, you know, basically blocking a few different types of important metabolic pathways that end up, you know, feeling like, you know, you don't have the energy. But there's probably something more going on there. I think people that have experienced the waves of COVID, you know, at every, you know, 5 p.m. or at, you know, sunset, literally like a vampire virus, like a bat virus, right? But people will experience like waves at sunset. What's going on there? That's I think that's going to be a very telling investigation as well. But essentially, either that's like daily replication or something, but there's something going on. This thing is a spooky virus. It's a very spooky virus. We've talked about this from other angles in recent broadcasts. But essentially, you know, they're going to come out one day and tell you this is the fucking doomsday I am legend virus. And everybody that's been infected basically either has to go to Africa or they must be exterminated. Something like that. You know, there's going to be some kind of world quarantine program that happens, chances are. And they're going to have to figure out where all the sick people go. Where do all the sick people go? Australia, Africa, Mexico, andale. You know what I mean? So, but this thing is not going away. The fact that you've got, you know, so many people talking about chronic long haul COVID tells you that this is not going away, right? So anyways, we're going to come back with another broadcast on the situation on the West Coast. We'll leave it there for this show. But tell us what you think. You know, send us your hate mail on Twitter or Gmail or something. Tell us what you think about all of this. And big shout out to everybody in the audience. Not sure if you guys are still out there, really. It's been so, you know, bad on the internet lately. But real bad. Yeah, I see a few of you out there. Like and share. We're just warming up out there. But yeah, the internet is so bad these days. I think we broke it, man. We broke it so hard. You know, we can't broadcast anywhere. They're now sending us notifications like that don't even make sense. Really. But Fakebook is gone. ScrewTube. I mean, this channel is going to go dark soon, and we'll be on BitChute. Nobody will find us there. That's okay. I'm going to write a book or do some podcasts. We're testing out podcasts on all sorts of different platforms. Check that out on our website, stfnreport.com. If you're a podcast kind of person, we'll be on the iTunes Store, Google Play, Spotify, all that stuff. See what happens there. But find our podcasts and spread them around, see if we can get that to lift off. But we need to lift off somewhere, ladies and gentlemen. But we've got new ideas. We'd like to start a band.video type of broadcast or platform, we should say. Mel Gibson says he's got to reset the chat every time. I mean, ScrewTube is just so fucked. It's not even worth it. You know, we're here because for the time being, there's nothing else. But something else is coming. And I would love nothing better than to never have to deal with ScrewTube or Fakebook or any of these, libtards from California. But they're getting theirs, bro. This virus came for them. And little do they understand. But from our point of view, I mean, don't go out there, without a condom just yet. Keep it on. Keep your face mask on because at least in public places, we don't say sit there, 24/7 breathing, through a face mask. But if you're going to go indoors right now into a store, I would wear a mask, an FFP2 mask, pharmaceutical grade, not like the painter's mask, but it's another story if you can find them. Gotta go, ladies and gentlemen. We'll be back in about an hour, hopefully, with another broadcast. And look, I didn't know how this one was going to turn out, but I hope it kind of gave you guys something to think about. And yeah, we really didn't spend a whole lot of time on any of this stuff, but I don't think it really would have interested people much beyond the title anyways. And the idea, I think, is what's important. Like all of these little different things here, this represents like a package that pirates, hijacks, all sorts of functions in the body and the cell. And it's much more than just like some kind of little blob that replicates. This is much worse than some kind of thing that replicates like some kind of endless copy machine. This is not just some kind of endless copy machine. That's what I think that's like the big takeaway. And the big takeaway as well is labs that are running these tests based on these codes. It's coming from a virus into another virus. It seems like it's a virus. Right. It seems like the world is round, but you can't help but think it's flat. You know what I mean? But at the end of the day, you have to say to yourself, is there HIV? Is there cancer? Is there fires on the West Coast? Is anything we see on TV real? And, some of the floods are, some of the floods aren't. Gotta go. Till the next time. If you're listening to this, you are.